Hello ladies and gentlemen, we are from Group 3. Today we would like to explain about several types of standardized scores that are often used in educational measurement. The topics we will discuss are percentiles, Z-scores, T-scores, CEEB scores, and Standard 9. These scores help us understand students' performance by comparing one score to others in the same group. So, let's start our presentation with percentiles.
Hello everybody, my name is Nashwa Aulia Putri. My last three-digit number is 086. In this opportunity, I would like to explain to you about percentiles. Percentiles are like quartiles, except that percentiles divide the set of data into 100 equal parts, while quartiles divide the set of data into 4 equal parts. Percentiles measure position from the bottom. Percentiles are most often used for determining the relative standing of an individual in a population, or the rank position of the individual. Some of the most popular uses for percentiles are connected with test scores and graduation standings. Alright, let's move on to the definition 1 of percentile. A percentile is a measure that tell us what percent of the total frequency score at or below that measure. A percentile rank is the percentage of scores that fall at or below a given score. Here's the formula. To find the percentile rank of a score X out of a set of n scores where X is included, B plus 1/2 of E divided by n multiplied by 100 equals percentile ranks, where B stands for number of scores below X, E stands for number of scores equal to X, N stands for number of scores. For example, if Jason graduated 25th out of class of 150 students, then 125 students were ranked below Jason. Jason percentiles rank would be 125 plus 0.5 times 1 divided by 150 equals 125.5 divided by 150, which equals 0.836, or the 84th percentile. Jason's standing in the class at 84th percentiles is higher than 84% of the graduates. Good job, Jason. Next, definition 2 of percentile is a measure that tells us what percent of the total frequency scored below that measure. A percentile rank is the percentage of scores that fall below a given score. Here is the formula to find the percentile rank of a score X out of a set of n scores where X is not included. Number of scores below X divided by n times 100 equals percentile rank. For example, if Jason graduated 25th out of a class of 150 students, then 125 students were ranked below Jason. Jason's percentile rank would be 125 divided by 150 equals 0.83 equals 83rd percentile. Jason's standing in class at 83rd percentile is higher than 83% of the graduates. Good job, Jason. The slight difference in these two definitions can lead to significantly different answers when dealing with small amounts of data. Examples: finding percentiles. 1. The math test scores were these. Find the percentile rank for a score of 84 on this test. Be sure the scores are ordered from smallest to largest. Look at the 84. First, I will explain the solution using the formula. The formula for percentile rank is B plus half of E divided by N times 100. In this data, B is the number of scores below 84, which is 8. E is the number of scores equal to 84, which is 2. And N is the total number of scores, which is 20. So, we substitute the numbers into formula. 8 plus half of 2 equals 9. 9 9 divided by 20 times of 100 equals 45. Therefore, the score of 84 is at the 45th percentile. Next, I will explain this solution using visualization. First, the data is ordered from the smallest to the largest score. Because there are two scores equal to 84, one score is counted as below 84 and the other is counted as above 84. After grouping the data, there are 9 scores below 84 out of 20 total score. To find the percentile rank, we divide 9 by 20 and multiply by 100. The result is 45%. So, using visualization, the score 84 is also at the 45th percentile. 2. The math test scores were these. Find the percentiles rank for a score of 86 on this test. Be sure the scores are ordered from smallest to largest. Look at the 86. First, I will explain the solution using the formula again. The formula for percentile rank is B plus half of E divided by N times 100. In this data, B is the number of scores below 86, which is 11. E is the number of the equal to 86, which is 1. And N is the total number of scores, which is 20. So we substitute the values into formula. 11 plus half of 1 equals 11.5. 11.5 divided by 20 times 100 equals 57.5, which is rounded to 58th percentile. Next, I will explain the solution using visualization. Since there is only one value equal to 86, it is counted as half a data value for the group below 86 and half a data value for the group above 86. After grouping the data, there are 11.5 scores below 86 out of 20 total scores. To find the percentile rank, we divide 11.5 by 20 and multiply by 100. The result is 57.5%, which is rounded to the 58th percentile. So using visualization, the score of 86 is at the 58th percentiles. Calculating percentiles. To calculate the kth percentiles, where k is any number between 1 and 100, follow these steps. First, order all the numbers in the data set from the smallest to the largest. Second, multiply k percent by the total number of data values, n. 3a. If the result from step 2 is not a whole number, round it up to the nearest whole number and continue to step b. 3b. Count the data values from left to right, from the smallest to the largest, until you reach the position obtained in step 3a. The value at that position is the kth percentile. Fourth, if the result from step 2 is a whole number, count the data values from left to right until you reach that position. The kth percentile is the average of the value at that position and the value that directly follows it. Example, suppose there are 25 test scores, and when they are ordered from the lowest to the highest, the scores are these. To find the 90th percentile, we multiply 90% by the total number of scores. 0.90 times 25 equals 22.5. Because the result is not a whole number, we round it up to 23. Next, we count the data from the smallest value to the 23rd score. The 23rd score is 98. So 98 is the 90th percentile of this data set. To find the 20th percentile, we multiply 20% by the total number of scores. 0.20 times 25 equals 5. Because the result is a whole number, the 20th percentile is the average of the fifth and sixth value in the data set. The fifth value is 62 and the sixth value is 66. The average of 62 and 66 is 64. So the 20th percentile is 64. The median, which is the 50th percentile, is the 13th score in the ordered data set. The 13th score is 77. Alright, that's all for me. Thank you.
Hello everyone, my name is Waranoren Ramadhani and the last number of my student ID is 088. Here I would like to explain three types of standardized scores that are commonly used in educational measurement. These scores are Z-scores, T-scores, and CEEB scores. Standardized scores are important because they help us understand how a person's score compares to other people's scores in the same group. So instead of looking at a score alone, we can see its position in relation to the average. In this presentation, I will explain these three scores step by step, starting from the most basic one, which is the Z-score, then moving on to T-scores, and finally CEEB scores. Let's talk about Z-scores. A Z-score, which is also known as a Z-value, a standard score or a normal score, is used to describe how a particular score fits into an overall group of scores. In simple terms, a Z-score tells us where a score stands compared to other scores in the same distribution. It is important to understand that a Z-score is not a new score. It is an ordinary score that has been transformed. The purpose of this transformation is to help us better understand the location of that score in relation to the mean, or the average of the group. One key characteristic of Z-scores is that they always have a mean of 0 and a standard deviation of 1. Because of this, Z-scores are very useful when we want to compare scores from different tests, even if the original tests have different scales. Now let's look at the formula for calculating of Z-score. The formula is Z equals x minus x bar divided by s. In this formula, x represents a particular value of the variable, x bar represents the mean, and s represents the standard deviation. So basically, this formula shows us how far a score is from the mean, and it measures that distance using standard deviation as the unit. If a Z-score is positive, it means the score is above the mean. If a Z-score is negative, it means the score is below the mean. And if the Z-score is 0, it means the score is exactly at the mean. This is why these scores are very helpful for understanding the relative position of a score. Now, let's move on to T-scores. Like Z-scores, T-scores are also used to tell individuals how far their score is from the mean. However, T-scores are designed to be easier to understand, especially when the results need to be explained to parents or people who are not familiar with statistics. T-scores have a mean of 50 and a standard deviation of 10. Because of this, most T-scores are centered around the number 50, which feels more familiar and less confusing than seeing negative numbers, as we often see in Z-scores. For example, if a student's raw score is converted into a T-score and the result is 70, this means the student's score is 20 points above the mean. This way of reporting scores makes interpretation much simpler. Instead of explaining that a student is 2 standard deviation above the mean, we can simply say that the student have a T-score of 70. Now let's look at the formula used to convert a Z-score into a T-score. The formula is T equals 10 times Z plus 50. So these scores are directly based on Z-scores, but they are rescaled to make them more practical and user-friendly. One clear advantage of this score is that they are relatively easy to explain, especially when reporting students' assessment scores to parents. Finally, let's talk about CEEB scores. CEEB stands for College Entrance Examination Board. CEEB scores are another variation of the Z-score, and they are often reported in the United States, especially in the context of college entrance examinations. Similar to T-scores, CEEB scores are also based on Z-scores, but they use a different numerical scale. Now, let's look at the formula used to convert a Z-score into a CEEB score. The formula is CEEB equals 100 times Z plus 500. This type of scoring system produced larger numbers, which are commonly seen in standardized tests such as college entrance exams. The scale is designed to show that average performance is centered around 500, even though the numbers in CEEB scores look very different from Z-scores and T-scores. The basic idea remains the same. CEEB scores still show how far a score is from the mean based on standard deviation.
Hello everyone, my name is Muhammad Shahrul Irgaza and my last student number is 087. In this video, I will explain stand-in, also known as Standard 9 in a simple and easy way. Stand-in stands for Standard 9. It is a method used to convert test scores into a scale from 1 to 9. In the stand-in scale, 1 represents very low performance and the 9 represents very high performance and 5 represents the average score. The mean of stand-in is 5 and the standard deviation is 2. Stand-in is similar to Z-scores and T-scores, but there is one important difference. Z-scores and T-scores can be decimals, such as 0.5 or 1.75. However, stand-in scores are always whole numbers from 1 to 9. Stand-in does not show how the original test score. Instead, it shows a person's position compared to others in the same group. Stand-in is based on the concept of normal distribution, also known as the bell curve. In a normal distribution, most people are in the middle. Fewer people are at the very low and very high ends. The bell curve is divided into 9 sections, and each section represents one stand-in score. The middle part of the curve is stand-in 5 because most test takers are around the average. The left side represents lower stand-in scores and the right side represents higher stand-in scores. That is why stand-in 1 and stand-in 9 represents only a small percentage of people. Each stand-in represents a specific percentage of test takers. Stand-in 1, the lowest 4%, stand-in 2, the next 7%, stand-in 3, the next 12%, stand-in 4 is the next 17%, stand-in 5, the middle 20%, stand-in 6 is the next 17%, stand-in 7, the next 12%, the stand-in 8, the next 7%, stand-in 9, the highest 4%. This shows that standing focuses on relative position, not exact scores. Here is the conclusion. A percentile is a measure that indicates the percentage of scores in a distribution that fall at or below a particular value, while a percentile rank refers to the percentage of scores that fall at or below a given score. Z-score is an ordinary score transformed so that it better describes the location of the score in a distribution. T-score are used to tell individuals how far their score is from the mean. CEEB scores are another variation of the Z-score and are often reported in the United States. Standard 9 is a method or scaling test. Scores on a 9-point standard scale with a mean of 5 and standard deviation of 2. Alright, I think that's all. Thank you for watching.